question 6. So here we are given with a binomial expansion of the term 1 plus kx to the power of n. If I follow the formula of the binomial expansion, it is given in the booklet, I will get here 1 to the power of n plus n C1 times 1 to the power of n minus 1 times kx to the power of 1. Now the second term, or the third term, is n C2 times 1 to the power of n minus 2 times kx to the power of 2. And those numbers here, nc1 and c2, can be calculated using the formula nc of r, which is the factorial of n over the factorial of r times the factorial of n minus r. So if I want to do it for nc1, I will get here the factorial of n over 1 factorial times n minus 1 factorial. N factorial over n minus 1 factorial is n, and the factorial of 1 is 1. So this number nc1 is n, and if I return to this term and I write it down fully, I got here n times 1 to the power of n minus 1 is 1 times kx to the power of 1, which is kx. And now if I look at the expansion that they gave, I see that the term with x had a coefficient 9 over 2. This is the term with x, and therefore I can identify that nk is 9 over 2. Now I will move on and will calculate nc2. So here I get the factorial of n over factorial of 2 times n minus 2 factorial. So n factorial is the multiplication of all numbers from 1 until n. 2 factorial is 2, and n minus 2 factorial is the multiplication of all numbers starting with 1 and going till n minus 2. Now in the denominator I multiply all the numbers till n. This means I go 1 times 2 times 3 points n minus 1 n minus 2 n minus 1 times n. This is the multiplication of all numbers till n. And I write it down in this way so I can see that the multiplication of all numbers from 1 till n minus 2 here and here can be struck down. They cancel out. And I left with n minus 1 times n over 2. Now I go back, I want to write down this complete term. So I know that the nc2 is this thing, times 1 to the power of n minus 2, that is simply 1, and times kx to the power of 2, which is k squared x squared. And again, I go to the binomial expansion then that they provided, and I look on the term with x squared, and the coefficient of it is 15k squared. Then I can recognize here that the coefficient of x squared should be 15k squared, and from here I get an equation. I can divide by k squared, and I get that n minus 1 times n over 2 equals 15, and if I do the multiplication, this is n squared minus n minus 30 equals 0. This is a quadratic equation with n. I can solve it using the quadratic equation formula, or I can simply factor this term. It will be n minus 6 times n plus 5, then I say the multiplication is minus 30, and the addition will be minus 6n plus 5n is minus n. So here I get that n equals 6 and n equals minus 5. N equals minus 5 cannot be, because n is positive, it is given. So I left with n equals 6, and in order to find the value of q, I use this equation that I already got, where nk is 9 over 2. So if nk is 9 over 2, I substitute n, and I get that 6k is 9 over 2, and k is 9 over 12, or if I simplify this term and divide numerator and denominator by 3, I get that k is 3 over 4.